Hello everyone. Let us solve the definition of reading a number from the user, preferably an integer number, and check whether the digits are in increasing order. That is, the digit to the left is smaller than the digit to the right. And in this video, we are going to use the number method of checking this. Now, if you know already, when you extract a digit from the number, you are basically extracting the rightmost digit, which means that we will have to make a comparison of the previous digit being smaller than the current digit. That is, the digit to the right will be bigger than the digit to the left. So for this, let us create a few variables and do the conversions. So the first thing I will need is to convert the value into a number. Now we want to make sure that the number is an integer number. You can make an assumption and go ahead and solve this definition. But if you want to be a little more specific, you can do the conversion and check whether it is integer and that it is positive or not, right? So for our safety, we're going to go ahead and do that. So I'm going to not only convert b into its integer, but I'm also going to go ahead and use the math floor, not the math floor, the math absolute, to convert this into its absolute value so that if b is equal to c, then I know it is for sure a integer positive number. So if yes, it is a integer positive number, we will do something, and otherwise we'll throw a message to the user that it is okay, it's an invalid number, and we are done. All right, so let us look at the logic now. The first thing we're going to do is, again, we'll have to make one more check at this point. Not only is it a positive integer, and we also make sure that it is greater than 0. Because if the number is 0, then you don't really need to check whether the digit to the left and the right and all. So the first thing I'm going to do is we would need two numbers. So let's say number 1 and number 2. And all right, let me create one more variable. Okay, so let us take number 1 as b modulo 10, which would allow us to extract the last digit. And then I'm making sure that the number is converted into the new number before we enter into the loop. So I'm extracting the first digit, and I'm going to go ahead and write my loop saying while b is greater than 0, I'm going to extract the next digit, which is right now the last digit, and I'll convert the number back into its new form by reducing the number. All right, now I would need one more variable, and I go with flag as 0. So if n1 is greater than n2, no, we'll go the other way. If n1 is less than or equal to n2, then I would change the flag to 1. So this simply means n1 would be the last digit that I had extracted, and n2 is the the one previous to the last digit. So obviously n2 must be less than n1. So if n1 is less than n2 or n1 is equal to n2, I'm putting the flag as 1. So what we will do is once the while loop is over, we're going to check what is the value of flag. If the flag is still 0, it means that all of them were in order, in decreasing order from the right to the left. And if the flag has changed to 1, you obviously know there was one sequence where there was a mismatch, meaning the left hand side digit was either greater than its right side digit or they were same, right? And now once this is done, this check is done. Now I'm going to shift n2 into n1. So the current digit becomes the last digit, and then we will proceed with this loop. Once this loop is over, we will just check if the value of flag is 0, we'll show a correct number message. Otherwise, we will show an incorrect message. And let us try running this code and checking out whether it's actually working or not. So let me try picking up a number. Hopefully it should say it is correct number. Um, okay, it says incorrect number. Okay, so so far it looks as if it's working. Okay, invalid number. Looks like it is working fine. I have not taken up a dry run. It's just a one-shot write, and I've just tested it directly here. But yes, if at all there's a problem with the logic, you know where to get me. So let me know if this logic is not working. Otherwise, just go ahead and rectify it, and you may find a better solution to this one. Take a dry run of this code and see if it is working fine in all situations. And I'll catch you in the next video with a new definition. Okay, for those of you who have requested the logic, the first thing I'm going to do is I'm going to take this out in the variable n1, and then I'm going to reduce the number to 123. So 4 is taken out. Now, when the loop begins, the first thing is tested is whether this is greater than 0. Yes, obviously. So the first thing that comes out inside the loop is this digit is extracted in n2, and the number is reduced to this. So it's just 12. Now, the comparison between an n1 and n2 will take place. Now, obviously, n1 is greater than n2, so flag still remains 0. Flag doesn't change. And then the last thing that happens in the while loop is that this value is shifted to n1. Now, in the next iteration, the number is 12, which is still greater than 0. So, the last digit being 2 will be extracted in n2. That's the first statement executed inside the while loop. And the number is reduced to this. Now, the condition is tested. Is n1 greater than n2? Yes. So the flag still remains 0. And then the last thing that happens inside the while loop is that this n2 is moved to n1. So this becomes n1. Now in the next iteration of the loop, because the number is 1, which is still greater than 0, this digit is extracted in n2, and the number is divided by 10 and floor is taken. So the number 1 is removed, and the only thing that remains in B is 0, which means the next iteration would not happen. Now, the comparison between these two is taken up, and n1 is still greater than n2. Hence, the flag does not change to 1, it still remains 0. And then what happens is this value of n2 is shifted to n1. But then the next iteration, because the number has changed to 0, b equals 0, the while loop is exited, and if you check the value of the flags, they are 0, which means that the there was no sequence where the left digit was greater than the right digit or the left digit was equal to the right digit. So on demand, I have given you the logic. Now you can take a dry run, take any samples, put it along with the code and check what happens in each of the situations. Hope this helps.